record. Okay, let's start. So the image consists of the basic structure of the decision tree. Every tree has a root node and like where the input are passed. As I said, the root node will consist of all of the dataset, and yeah, the whole root node will consist of all of the dataset passed, and the terminal node will contain the output at the end. So decision tree works on that. This root node is further divided into set of decision nodes where the results and the observation are conditionally based. So as I said, after feeding the dataset as a root node, we define certain set of parameters where a condition is being established, and after that, based on the condition, the dataset is divided into certain parameters, certain sub branches, and after that, these sub branches again will be divided into sub branches based on another condition or the same condition that is being given. So after reaching the final or the terminal node, the output will be generated. So it is been said that if node doesn't split into further node, this is called the leaf node or the terminal node. So terminal node is nothing but the last node of the last node of the whole of the tree. Okay. So there are certain parameters and areas that how you apply decision tree. So choose an attribute from your data set. So for that, just a second, yeah. So for that you need to choose an attribute from the data set. So which on which category or variable you will divide data set into sub branches. So you need to have certain attributes, like we can divide data set into based on the age category. So if we have a data set of mixed age category, we may divide the dataset into age group of 20, below 20, above 20, and like that. So dataset will be divided into two branches, below 20 and greater than 20. After that, we may divide again dataset that if we are having data of uh, above 20, we may divide into 60, below 60 and above 60. So based on the categories, we divide dataset into different trees structure. Calculate the significance of attribute in splitting of data. So this is like that we are defining the importance of our attributes, like what our attribute main focus is on splitting of the dataset, and split the dataset based on this, and we repeat this parameter until we reach the final outcome. Now, this is the next slide, which defines you how to create a decision tree. So I'll explain more on that in when we will do coding on decision tree. But just to go through with this, we shall discuss the code algorithm describing how decision tree is created, and these algorithms are completely dependent on the target variables. However, they vary from the algorithm used for classification and regression. So it's not that we are using both classification and regression here, but these depend totally depend on the target features. So if target is continuous or categorical, we will apply accordingly. There are several techniques that are used to decide how to split the given dataset. So based on the splitting of dataset, we will no, there are certain conditions. So yeah, so there are certain conditions upon which we will divide the dataset into different sub branches. So the main goal of the decision tree is to make the best split between the nodes. So we just do not split dataset into two branches like that only. We have certain rules and parameters, and we will find the best of the parameter to split the dataset. Not just we have to fine tune the model in such a way that the best parameter should be split into two categories or other categories. To do this, we need to have right decision rules. Now, moving forward in decision tree, we do have certain parameters and attributes uh, that need to be taught in order to proceed with the decision tree algorithm. So now the first one is Guinea impurity. So what is Guinea impurity? If all elements are correctly divided into different classes, the division is considered to be pure. Now, now we have parameters like pure Guinea impurity and impure Guinea impurity. So what is this? If all the data set that we are dividing into branches are all considered into different classes and the division is considered to be pure, so we say that it is pure Guinea impurity. And the Guinea impurity is used to gauge the likelihood that a randomly chosen example would be wrongly classified by a certain node. It is known that impurity measure since it gives us an idea of how the model differ from pure division. So just to just to go through with this, what is Guinea impurity? So basically, we have a parameters. Say we have a parameter that is divided into different classes, and we consider that it as a pure feature. Now comparing it with the next outcome we are obtaining, we compare with the previous pure Guinea impurity, and we compare and finalize that the outcome is coming out to be whether the outcome previous outcome and the current outcome is coming out to be either positive or a negative, and it is being correctly classified or not. That is the sub branches we are dividing. It decide from the previous outcome, and it accordingly suggests you that the classification is of pure or correct classified or an incorrect classified, wrongly classified. The degree of Guinea impurity scores it always between 0 to 1. Now this you need to remember that the degree of the Guinea impurity should be between 0 and 1, where 0 denotes that all the element belong to a certain class. That is, whenever we are dividing a data set into set of parameters, say A or and B. So let me draw it. So like we have two parameters A and B. We have divided data set into two branches, say A and B, and if all the element belong to class A, all the element belong to class A, we can say it is a 0 degree Guinea impurity. And if all the element belong to class B, we can say that it is a 0 degree. But if we have certain parameters in class A and certain parameters in class B, we can say that it is a degree lies between 0 to 1, and 1 denotes that the elements are randomly distributed along various classes. So we can say that the value lies between 0 to 1. So if the degree is 0, we can say that all of the data set lies in any one particular class, and 1 denotes that it is randomly mean distributed. Again, impurity of 0.5 denotes that the elements are distributed equally in both the class. So if we have 20 parameters in our data set, 20 object parameters, any you can say any, and if both of these are divided into see equal number of classes, so we can say that the Guinea impurity value will be degree of the Guinea impurity will be 0.5. The mathematical notation of given impurity Guinea impurity is given in the next slide. So we calculate the Guinea impurity using Guinea is equal to 1 minus summation of p ka whole square, where p is the probability of particular element belonging to a specific class. So based on the Guinea impurity, and we based on the data set, we calculate the Guinea impurity, and further we proceed with the classification of decision tree, or classifying our next data point into different categories. Now we have another parameters here after Guinea impurity, information gain. So in decision tree, what we do, we tend to maximize information gain and minimize entropy. So what is information gain? Information gain depicts the amount of information that is gained by an attribute. So it's clearly saying that it depicts the amount of information that has been generated and you conceive by an attribute. It tells us how important the attribute is. Okay, so information gain defines you the importance of a certain attribute in the dataset. Since decision tree construction is all about finding the right split nodes that assures high accuracy, so we tend to maintain high accuracy, and for that uh, we figure out that the information gain should be as high as possible. So this is the point, that highest information gain. We tend to have highest information gain in decision tree classification. Now the next parameter, so the information gain is nothing but we need to tune the parameter such that we obtain the maximum information gain and minimum entropy. Now moving forward with the next attribute in decision tree is chi-square test. So chi-square method works well if the target variables are categorical, like success, failure, yeah, high or low. So what happens in chi-square? We basically apply chi-square in the dataset that is of categorical in nature. That is, we have the target variable in different categories like low, medium, high, or like it is said that success or failure. So the core idea of algorithm is to find the statistical significance of variation that exists between subnode and the parent node. So whenever we apply chi-square, or we tend to apply chi-square, the main goal should be the statistical significance of the variation that exists between the subnode and the parent node. So like we have parent node and we have subnode, two subnode. So we tend to find the statistical significance between or the importance between the root 1 and sub branches 1. So we tend to find the statistical significance of the variation that exists between root parent or the root and the subnode. The mathematical equation is being derived here. So actual value minus expected value whole square divided by expected ka under root. So we tend to find the chi-square with the help of actual minus expected ka whole square upon expected ka overall under root value. Now moving forward with the decision tree, we have certain applications of decision tree in real world scenario, and it can be used in business management. It can be used in customer relation management, fraud statement detection, energy consumption, healthcare management, and fault diagnosis. So these are some of the examples being illustrated here for decision tree in real life scenario. Now, moving forward, as I told you that we have certain parameters that we need to tune so that we will obtain the best outcome and the maximum information gain in our decision tree algorithm. So we have criteria, splitter, maximum depth, minimum samples, and max leaf nodes. So these are the five hyperparameter that we need to tune it and think of what the value should be in order to get the maximum accuracy and information gain. So what is criterion? This parameter is used to measure the quality of the split. So criterion is nothing but it measures the how good we have splitted the dataset into different categories. The default value of this parameters is set to Guinea. So if criterion, say I'm denoting it by C, if it is Guinea, so it is a default parameters, and Guinea is what in the previous slide we have seen that Guinea calculates the purity of the dataset in our splitting. So this is the say default value of the criterion. Now moving with the splitter, this parameter is used to choose the split at each node. So splitter will decide the amount of data that will be splitted into different sub branches, subtrees. Now maximum depth, this is an integer parameter through which we can limit the depth of the tree. The default value is set to none. So if we need to decide the depth of the decision tree, we may change the value of maximum depth. Minimum sample split, this parameter is used to define the minimum number of a sample required to split an internal node. Okay, so this parameter is used to define the minimum number of sample required to split an internal node. Okay, so we have say I'm drawing the decision tree roughly. So what are internal nodes? Let me draw it first. So this is internal node, this is internal node. So it defines the parameter used to define the minimum number of sample required to split an internal node. So minimum sample split will define you that how much minimum number of sample you need to require in order to split these internal nodes. Okay, and maximum leaf node, the default value of maximum leaf node is set to none, and this parameter is used to grow a tree with maximum leaf in the best first fashion. Okay, so this parameter will defines you the maximum splitting of the dataset uh, at its leaf node. Now we have done with the theory part of the decision tree, and might be you have understood or might there be some doubt in your mind, but once we will proceed with the decision tree coding, your all concept will be cleared and you will easily be able to apply the decision tree in your dataset. So I'll move with the coding section in the later stage of the session, but I'll cover first SVM, which is our next topic. Or you want decision tree hands-on right now and then SVM? So should I start with the hands-on with decision tree, or should I start with SVM? Mm, any of you? Your suggestion?